Hello everyone, this is the Frugal Engineer. In this C# tutorial, I would like to tell you how asynchronous programming works in C#. Before we start the video, I would like to ask you, what type of execution would you prefer in your application that have a user interface? One that blocks the application until the individual tasks are finished, or one that remains responsive during the full execution process, no matter how many subprocesses your program has. Let's see my example here. This is a really simple Windows form app that has a few fields. By the way, as always in my videos, you will find the source code in the description below. Okay, so going back to my example, really simple what it does. We have two fields, number 1, number 2. We add here numbers. We press here the button calculate, and then we'll get here the result, the sum of those two numbers. So 2 and 2 will get a 4. The interesting part is we have this field that is called delay in seconds. If we add a number here, the program will take that amount of seconds to complete the sum calculation. It's just an example to show what happens in real scenarios where we need to do operations that take some time. And then here, really simple, every time we press 1, this number will go up. It just simulates that our program might have different tasks at the same time. So we add here a 2 and then a 3, and then here we add a delay in seconds. Look what happens when I check calculate. Now my program is blocked, I cannot do anything until this finishes. Now that it finished, we get the 5 result. But this, as you can agree, this can be confusing for the users because we block our program while some operation needs to finish. However, look what happened when it says here enable asynchronous execution when I check it here. And then now I set a 4 and a 4. And then again 5 delay seconds, so I calculate again. Oh wow, looks my program is not blocked anymore. And then after 5 seconds we get the result here. You will agree with me that this is a better behavior. This allows the program to continue working without getting blocked. If you continue with me, I will show you how you can do it and how you can apply it in the next section of the video. As an off-topic, I got the idea for this video while I was working on a new desktop program to manage stock portfolios using the Yahoo Finance API. If you remember, I have a video on my channel where I explain how that API works. The asynchronous execution will help my program to be responsive while fetching the stock prices from the Yahoo Finance API. Subscribe to my channel so you won't miss any of my future videos. Okay, let's do a quick review of what's the difference between synchronous and asynchronous execution. The big blue lines represent when a thread is active. In the synchronous execution, we can see that only one thread can be active at the same time. And you can see how the main class gets blocked while the other tasks finish. However, if we check the asynchronous execution, we can see how we can execute all tasks in parallel, the main program does not get blocked and remain responsive, and we finish the execution earlier. You can see how powerful an asynchronous execution can be when we have to execute tasks that might take some time to finish and we don't want to block the execution of the whole program. Example of that type of task might be API calls to external systems, reading from a database, waiting for the user to input something, etc. Of course, you will find this diagram and all the source code in the description below. Okay, so let's review now an example of a program that executes the task in a synchronous way, meaning that we can only execute one task at the same time. Really simple what we have. Basically, we call this function and we pass it an argument. In this case, it's an integer. And then in this function, what we do is we just generate a random number and we wait the amount of seconds. So here, for example, the first one will wait 5 seconds. The second call to this function will wait 3 seconds, and we will get here the random number. Then, after it finishes, we will write these results here, and then we will measure how much time it took to finish. I'm telling you, it will take 8 seconds because those tasks will need to be executed one after each other. So then, if we execute, we need to wait, and after 8 seconds, After 8 seconds, we can see that first we had to wait for the execution of the first task, the one that we wait 5 seconds, then the second one, the one that we wait 3 seconds, we generate, we show those random numbers, and then we have a 8 seconds wait. Let's see now a better example of how we can manage this with in an asynchronous way. Okay, so let's have a look at the same code, however adding a few changes that will help us to improve the performance. What we will do is add a few different changes that will allow us to execute the task in an asynchronous way. The first thing that you will notice is that we have the async word here, and also that we return the type task. We are not returning anything on the main, but this is necessary to allow the main to execute in an asynchronous way. Then we have the same waiting function, however you can see that we are returning here a task. We are not returning only an int, and this will make sense in a second. If we go to the function here we are returning a type task with the type int, and then we just generate the random number and we wait that number of seconds. However, check that we have an await here. The await will allow us to perform tasks without blocking the whole execution of the program, and then after that time we return the number. Here what we do when we call this function is we get that result on a type task that is defined with an int. We get those two values in a list, and this is the best way to, the most efficient way to wait for tasks to finish. And then while this list has elements, we await for task to finish, and then we have this simple if else here. If the first task has finished, we just then said, hey, the wait some time has finished, and this is the result. And then if it's the other task, the one that has finished, then we saw the second result. And then we remove that result from the list. This is a quite a good and efficient way, recommended by the documentation, the official recommendation from Microsoft. I will let that link in the description below, of course. And then once it's finished, we just show the execution time. As you can see, and I will prove it you now, the execution time will be only 5 seconds because those tasks will be executed at the same time. We just click here, and then it finishes. As you can see, both tasks start at the same time. The second task that was a shorter task finished before, and we have that number, and then the first task that was going to finish later because it took more time, then we got this result, and then the total execution time was only 5 seconds. As you can see, this is a really powerful tool because we didn't block the main function, we finished earlier, and then we managed to execute different tasks in parallel. And now you can start to understand why it makes so much sense to use this asynchronous programming in programs that expose a user interface. So going back to my original example, you can start to see how useful this asynchronous programming is. If you remember, I was adding here a number, another number, a delay in seconds. If I didn't have this option enabled, when I was calculating, the program was completely blocked. However, if I enable this option, let's change this value here, the program won't get blocked. As I said before, you will find this code in the description below. I will upload it to GitHub, so you can just download it, or you can just contact me and ask me any question. The code is not complex at all, really easy. If you watch my former videos, you will find a tutorial on how to work with forms. However, not much to say, just a really simple form with the functions that use the same logics that I defined. My recommendation, just get my code, start testing, and if you have any questions you can just check me, but it's the same, as I said, it's the same logic that we apply using the await, the async methods, and also waiting for task to finish. Well, this is everything I wanted to show you today. Remember that you will find all the materials, linked to the documentation and my source code in the description below. Please like and subscribe if you enjoyed the video. The feedback is always a good motivation to continue uploading videos. If you have any questions, maybe you can follow me on Twitter or join the new Discord server that I just created. Thank you so much for watching, until the next video.